Hello students, hope that all of you are doing good. Stay at home and be safe. During this lockdown period, don't go out of your houses. Okay, today I begin with the first chapter of Physics class 9th and the chapter is motion. All of you are familiar with this word motion. But in physics, what is the correct definition of the word motion? This is the definition. A body is said to be in motion if its position changes with time. I repeat, a body is said to be in motion if its position changes with time. Or we can also define it as if its position changes with another fixed body or another fixed point. See, if a body changes its position with respect to time or with respect to some other constant body, that body is said to be in motion. It's very simple. In our common language, when we say we are moving, a body is moving. So, this is all about motion. Now, there are different types of motion. This is what we are going to discuss in this chapter. So we will come across different types of motion in this chapter. Before we proceed to the different types of motion, let us discuss about two things: distance and displacement. Distance is a very common and familiar word to all of you, but what does it really mean in physics? Listen to the definition. Distance traveled by a body is the total length of the path covered by it. The total length of the path covered by a moving body is called distance. That means when you are traveling, you know that your vehicle may be going in different direction along the road, and finally you reaches your destination. So what is the distance traveled by you? The total length of the path covered by you. So distance means total length of the path covered by the moving body irrespective of direction. Clear? Now the second word is displacement. Displacement means the minimum distance between the starting point and the finishing point. I repeat, displacement is the minimum distance between the starting point and the finishing point. I will explain with an example, that is difference between distance and displacement. Suppose a body is starting from point A and then it goes to point B and then it goes to point C. Okay, what is the distance covered by this body? The distance covered by this body is AB plus BC. So distance is equal to AB plus BC. Suppose AB is 400 meter and BC is 300 meter. Then distance traveled by this body is 400 plus 300 is equal to say 700 meters. But what is the displacement? Displacement is the shortest distance between the starting point and the finishing point. That means AC is the displacement. So here the displacement is AC. Of course, this AC will be less than 700 because A to B is this way, then B to C is this way. So AC is the direct path between A and C. This is immaterial that whether there is a direct path connecting A and C or not. In physics, when we talk about displacement, we are seeing the direct gap between the starting point and the finishing point. Whether physically there is a path or route, it doesn't matter. So AC is the displacement, AB plus BC is the distance. So this is the basic difference between distance and displacement. Now, while seeing these two things, you can also notice one thing. Distance has no direction. From A to B, it was traveling in one direction. Then the direction is changed while moving from B to C. So, the point is to be noted. Distance has no direction. It can be in any direction. The total length of the path covered by the body in any direction is called distance. But when you see the displacement, it's a straight line. Always displacement will be a straight line because it is the shortest distance between the starting point and the finishing point. So it will always come as a straight line. And as we know, a straight line will always represent, or it will always have a direction also. So displacement will have a magnitude. Magnitude means the numerical value. Say, in this case, let us take for an example, AC is 500 meter. Then, displacement is not only 500 meter. We say 500 meter towards a particular direction. If I say this is northeast, is it? AC is towards northeast. So displacement in this case is 500 meter towards northeast. But what is distance? Only 700 meter, it has no direction. So I repeat the difference. Distance has no direction, but it has only a numerical value. Displacement has both numerical value, that is magnitude, and direction. So in physics, there are two types of physical quantities. Those having only magnitude and those having both magnitude and direction. Here, distance is a quantity which is represented only by its magnitude. But displacement is a quantity which is represented by both its magnitude and direction. So these two types of physical quantities are given two specific names. These are called scalar quantities and vector quantities. Scalar and vector. Scalar quantities are those quantities which are represented only by its magnitude. Vector quantities are those quantities which are represented by both magnitude and direction. So scalar has only magnitude. Vector has both magnitude and direction. Example for scalar quantities. Those quantities which have only magnitude are called scalar quantities. Give some example. We have seen the example. Distance. Distance is represented only by its magnitude. Time is represented only by its magnitude. What is the time? We may say what is the time now. Time has no direction. Another example, mass. Mass of a body has no direction, only magnitude. What else? Speed. Speed has no direction. So distance, time, mass, speed, length, breadth, height, area, volume, all these are scalar quantities because they are all represented only by its magnitude. Coming to vector quantity, let's see the examples. Just now we have seen, first one is displacement. Displacement is a vector quantity. Then weight is a vector quantity. Weight of the bodies, it is vector quantity. We will study in another chapter more about weight, why it is vector quantity. Then velocity. Velocity is another vector quantity. Acceleration is a vector quantity. Force is a vector quantity because displacement, weight, velocity, acceleration, force, all these quantities are acting always in a particular direction. So those physical quantities which are represented by its magnitude and direction are called vector quantities. Those which are represented by only magnitude are called scalar quantities. Now let's discuss more about different types of motion. The first type that we are going to discuss now is uniform motion and non-uniform motion. First one is uniform motion. Listen carefully what is meant by uniform motion. If a body travels in a straight line and covers equal distance in equal interval of time, it is said to be uniform motion. I repeat, a body is traveling in a straight line and it covers equal distance in equal interval of time. How is it possible? How is it possible for a body to cover equal distance in every equal interval of time? Suppose you are driving your car or any vehicle, and how can you cover equal distance in equal interval of time? If the car is moving with constant speed, then it can cover equal distance in every equal interval of time. Suppose you are driving the car at a constant speed of 80 km per hour. What does it mean? In 1 hour, your car will cover 80 km. So, what will be the distance covered by the car in the next 1 hour? That is in the second hour, again 80 km. If you can drive the car at a constant speed of 80 km per hour, then in every 1 hour, that car will cover the same distance 80 km, 80 km, 80 km. Such type of motion is called uniform motion. I repeat, if a body travels in a straight line and covers equal distance in equal interval of time, the body is said to be in uniform motion. Now, what is non-uniform motion? Non-uniform motion. Very simple. A body is traveling in a straight line but covers unequal distance in equal interval of time. If a body covers unequal distance in equal interval of time, it is said to be in non-uniform motion. Actually, when we are traveling on the road, we are in non-uniform motion because we cannot drive a car at a constant speed for a long period of time because there may be obstacles on the road. Sometimes you have to stop, sometimes you have to decrease the speed, sometimes you will increase the speed. So it is not uniform motion. So the actual motion of our vehicles on the road is non-uniform motion. So I repeat, if a body travels in a straight line and covers unequal distance in equal interval of time. Interval of time is same. See the distance covered by you in every 1 hour gap. In every 1 hour, you are covering different distances. Such motion is called non-uniform motion. So, in uniform motion, body covers equal distance in equal interval of time. Non-uniform motion, body covers unequal distance in equal interval of time. Next term is speed. All of you are familiar with this word speed. You might have studied in smaller class also. Once again, I will define speed in physics. Speed is the distance traveled by a body in a unit time. The distance traveled by a body in unit time is called speed, or speed is equal to distance traveled upon time taken. Distance traveled upon time taken. Just now we have studied distance is a scalar quantity. Distance can be in any direction. It is the total length of the path covered by the body. So, speed is equal to distance traveled upon time taken. Since distance traveled is a scalar quantity, time is also a scalar quantity, speed is a scalar quantity. That way I have written the example, speed for scalar quantity. Because speed is distance traveled upon time taken. Since distance and time are scalar, speed is also scalar. Now, another word is velocity. Now it's the time for you to know the difference between speed and velocity. So far you might not have studied about it. Velocity and speed are not the same. Velocity is speed with the direction. Speed with the direction is called velocity, or velocity is equal to displacement upon time taken. So, for displacement what is needed? The body must be traveling in a particular direction without changing the direction. Suppose a body is moving in a particular direction on a straight line path, then that body has velocity. But if the body moves in any desired direction, changing the direction, then that body is not moving with velocity, but that body is moving with speed. When the body is traveling in a particular direction without changing its direction, for example, aeroplanes, after takeoff, attaining the particular desired height, it will be traveling in the same direction. So that time, an aeroplane is moving with velocity. But on the roads, normally when we travel, we are taking different directions. So that time that body has, or vehicles have speed. So this is the difference between speed and velocity. So velocity is equal to displacement upon time taken. And we know that displacement is a vector quantity. So velocity is also vector quantity. Speed is a scalar quantity. Velocity is a vector quantity. I think it's clear. Our next point is acceleration. What is the meaning of the word acceleration. All of you know that there is an accelerator on your motorcycle, car, everywhere. Accelerator. What is the purpose of this accelerator? It is to increase the speed, is it? Or decrease the speed. So accelerator is to accelerate the speed, means increase the speed. So what is acceleration? The rate of change of velocity is called acceleration. The rate at which the velocity of a body is increasing is called acceleration. I repeat the definition. The rate of change of velocity of a moving body is called its acceleration. Acceleration is represented by small letter A. Rate of change of velocity means the rate at which velocity is changing. So acceleration is equal to final velocity minus initial velocity upon time taken. Final velocity of a body is represented by small letter v. Initial velocity is represented by small letter u and time small letter t. So acceleration A is equal to v minus u upon t. Final velocity v minus initial velocity u upon time taken t. So acceleration is also a vector quantity because it is the rate of change of velocity. Now, what will be the SI unit of acceleration? I don't know whether you are familiar with SI unit or not. SI unit means Standard International Unit. SI unit. Standard International is the full form of SI. See, in science is an international subject. It is taught all over the world. The science is fact, so it is same all over the world. But what happens? In some countries, in some places, different units are followed. For length, for area, for mass, weight, different units are followed in different countries or different parts of the world. So when a student from India goes to another country for his studies, if the units are different, then that will create problem. So some units are internationally accepted in physics. In early time it was not so. For example, you might have heard in India, we use different old traditional units for measuring the length. Even today, length is measured in, you can measure the length in meter, kilometer, mile, gauge, angul, foot. All these are different units measured for measuring the length. Is it? Sometimes we measure the length by using our feet. It is called foot. Inch. Then yard, then all these that I have explained just now. So it will create a problem. So some units are fixed all over the world. So that units which are internationally accepted in physics are called SI units. And whenever you put the unit of any physical quantity, now onwards, you have to use only SI units. So SI unit means Standard International Units which are universally accepted. So let us see the SI unit of acceleration. V and U are measured in meter per second. What is velocity? Displacement upon time taken. So meter per second. Meter per second upon time. SI unit of time is second. SI unit of distance is meter. SI unit of time is second. So SI unit of velocity is meter per second. SI unit of speed is also meter per second. So meter per second upon second. So the SI unit of acceleration is meter per second square. The SI unit of acceleration is meter per second square. So it is also a vector quantity. Now the next word is called retardation. Retardation. Retardation is nothing but negative acceleration. When the velocity increases, we say acceleration. In the same way, when the velocity decreases, it is called retardation. So negative acceleration is called retardation. Formula for retardation will also remain the same. But when will we have retardation? When the final velocity is less and the initial velocity is more, then the body will have retardation. A car moving at 100 km per second is applying brake and coming to rest to 0 km per hour. So, initial velocity was 100 and final velocity is 0. So, when you do V minus U, it will be 0 minus 100. So, the retardation value will be always minus. So, formula for retardation is same as acceleration. The only thing is that while calculating retardation, final velocity will be lesser than initial velocity. So, the value will come in minus. So, SI unit also will remain the same. Meter per second is the SI unit of retardation also. So, that's all for today. I hope you understood the basic facts, basic things of the chapter motion. Please ask your doubts in comment.